We're now going to take a look at Le Chatelier's principle. Now, what Le Chatelier's principle says is it's indicating if I have a system that is at dynamic equilibrium. You take a look at the equation that's shown. 4NO gas plus 6H2O gas yields 4NH3 gas, 5O2 gas plus energy. Now, what this is saying is that at some point, the production of the NH3, the O2, and the energy, that production slows down because the NH3, O2, and the energy goes in reverse and begins to now generate the reactants again. And eventually they balance out. But now what Le Chatelier says is, if you were to now disturb that system, if you were to, for example, add energy or take out energy, what if you added water or took out water? What will the system do if you made a change in that equilibrium? Now, if you recall, we had the analogy of people in a dance club. And the people in the dance club had tall hats, but some of them were bald. Let me try to draw that dance club out very good if I can. So on this side, there were top hats, and there were bald. And over here, there are top hats, and there are bald. And everybody's dancing around. This is at equilibrium. But now what we're going to do is we're going to take out a top hat, add top hats, take out bald people, add bald people. And we're asking the question is, what does the dance room do if we change things around in there? So let's now take a look at the questions that get asked about that. If we were to remove heat, if you remove heat, that means you're removing the energy from the reaction. So what's happening is, let's imagine energy is a top hat. So here's the top hat here, and the bouncer starts to throw out all these top hats. We're throwing out the extra energy. What happens is that all of the top hats and bald people from this side will then go over here because there's more space. So what would happen is the reaction would go to the right in an effort to compensate for the loss of the top hats. So if you remove the heat, the reaction then would shift to the right. Now let's take a look at another situation. What if you added NO? If you add NO, then what you are basically doing is the bouncer is taking top hats from outside and shoving them in here. The dance floor gets really crowded because they're jumping top hats in here. The result is the whole thing would shift to the right. And if you shift it to the right, then you would have the NH3, the oxygen, and the heat would all increase as a response to the addition of the NO. What about a removal of NH3? If you remove the NH3, it's again like the bouncer throwing out the bald people. If you throw out bald people from here, the whole reaction shifts to the right as it tries to compensate or take advantage of the increased spacing on the dance floor. Now, increasing pressure, that's a slightly different idea. Let's take a look at the role of pressure. Here we have our top hats. That's a pretty bad top hat. Let's try that again.
Speak out
Speak out louder.
They can hear you.
Okay.
You, when you talk to yourself.
I always talk to myself. No,
Because you don't want silence.
no, I agree. I agree. Just keep occupying it. All right. Let's take a look at this idea of pressure. We're going to use our example of top hats and bald people. Imagine we have bald people over here and we have top hats over here. But you'll notice that the top hats and the bald people are all separate from each other. This over here is an unusual dance area. Here, the bald people put the top hat people on their shoulders. So you have all these bald people with the top hats on top of them. Now the reason why there's a big advantage in doing that is you don't occupy as much floor space. And so when in fact you have combined, you're much more efficient with your floor space. Now let's take an example, which is this. Let's now cause this side of the room to get really squeezed in. Let's take away surface of the dance floor. What will happen is the top hats and the balds start to get squeezed over here. These guys don't get squeezed as much because by stacking on top of each other, they're much more efficient. So when I have less volume, or in the case of a gas, if I start to have more and more pressure, you're going to drive the system to where there are fewer elements existing. So take a look now at the equation. We have 4 NOs, we have 6 H2Os. They're in a gas state. If you look at the ratios, there are 10 moles of molecules. 4 NO, 6 H2Os, that's 10. Let's take a look at the right. I've got 4 NH3s, I got 5 O2. That's only 9. So what happens is, if you were to increase the pressure, there are 10 moles on the left, there's only 9 moles on the right. And so what will happen is the system will be driven to the right because there's less moles of gas are going to be dealt with.